Hi, everyone. Good to see you joining. How are you? Let's wait just a couple more minutes. There is still people joining, so let's just wait for a bit. Okay, I think we are all, so it means we can start. Again, hi, everyone. Welcome to this YData Fabric workshop. Um, just as a quick reminder, this is a recorded session. Our goal with this recording is to be able to share with the ones that were not able to join us, but also to send you as a follow-up so you can recap or revisit some of the topics that we have discussed today. This workshop, um, it's about showing how you can develop in a data-centric approach a specific use case while leveraging YData Fabric as a data science workbench. The use case that we bring today is focused on customer churn. And for the session today, you can expect a structure that we will start with a small recap on YData's product capabilities and features, a very small one. I promise just to put everyone in the same page, or even to just revisit uh, some of the features that you already know. Afterwards, we will deep dive into how we have developed this use case. And last but not least, of course, everyone will get the chance to make questions and eventually even ask for more details or a deeper dive in some of the modules that we will be exploring today. Without further ado, I'll share my screen and let's start. So here is my workspace, as you can see. So this is where, as a user of YData's product, I'll be developing my use case. This is as a user of the platform, I do have several workspaces. I have my own, but I also have shared with my team the customer churn project. So here in my account, I just added the emails of the members of the team that will be working with me to build this use case. And for that reason, all of them have access to the project that we have set as customer churn. Here in the landing page of the project, I'm able to check some basic and simple elements of the project itself, how it is being composed, uh, which in a more specific way translates into knowing how many labs is my team using or leveraging to develop this use case, how complex is it in terms of the number of data sources available, how many do we have, how many are we leveraging, how many synthesizers were created for the purpose of delivering the use case, how many labs are currently running. This is very useful for optimization of infrastructure costs, for example. So this is where, as for example, a team lead, I can have some of the metrics related with the status of development of my project. But of course, we are here to develop the use case itself. So it means that we have to start by the data. We need data to have it developed. For this use case, we have selected a data set from Kaggle. Of course, bear in mind that this is a public data set, which means that in a nutshell, we can call it a more well-behaved data, which means that we'll have a few less challenges when compared to the data sets that many of you find within your organizations, of course. But anyways, this customer churn data set has already a few challenges that are useful to showcase how you can benefit from a data-centric approach. Before jumping into the specifics or the flow of the use case, as a quick recap, YData includes several features, and one of them, the data sources. This is a feature that data scientists or myself as a data scientist find it really useful to easily integrate the workbench with the different sources of data or information within an organization. It is quite flexible and scalable in a way that you can consume your historical data from the storages you have already within your organization, for instance. Yeah, we have as well the labs, which is what I would consider to be the experimentation module where, as a data scientist, I can further explore the data that I have. I can develop a full solution by leveraging tools that I'm already used to, like Jupyter Notebooks, VS Code, or even leverage packages such as scikit-learn combined with proprietary features from YData, such as the synthesizers, making it a very experimental environment, very easy, very familiar, and very integratable with other elements within your infrastructures, but also if I want to integrate with my own development locally, this is very easy as we support the tools that are already used by data scientists in a nutshell. Third, but one of my favorites for sure, the synthesizers. This is the module that you can use through the UI to, in a very easy manner, consume a data source, configure the synthesis process, and afterwards be able to generate new synthetic data that can be used for purposes of privacy, for example, in case you have sensitivity while sharing some of the data, but you also can benefit to, for example, for purposes of augmentation, bias, or fairness. Last but not the least, the pipelines is definitely the module that we use and explore to deliver experimentation at scale. So this is the glue that allow to combine all the elements that we mentioned previously and allow us to benefit in the full power of the data-centric approach with a logic of building block kind of development that is so important um, to experiment, track, and compare results of different decisions at the step of the data preparation. Now that we have very quickly recapped on each and every feature of the workbench, let's start with the flow for the use case. As a data scientist, of course, my first and main objective is to get the data that I need. For that reason, I integrated my data within the platform. For that purpose, I needed to create a connector. At YData Workbench, you can very easily decouple or detach the connector creation for a project between two different profiles. For instance, you can have your security team or even your data management team holding the credentials and, for example, creating a connector that afterwards can be reused by data scientists to create or to consume the data that they need to work. So this can be done, for example, as simple as doing creation of a connector, well, where we select from multiple data storages, such from RDBMSs to file system or any other data source upon request. Of course, we invested a lot in historical data consumption, and that's exactly what we allow at scale to be done here. This connector is then stored at the level of the project, kept at the level of the project, and made available for the creation of data sets from it, that same connector. As I have already my connector defined, I can select it and then provide the details like the file path or the query that will be the source of my data or the data to be consumed and explored. For this use case in particular, I have leveraged the Google Cloud Storage to read one CSV file, the customer churn data that contains historical information on customers for a telco and whether they have churned or not. Um, Now that I have consumed the data, as a data scientist, I want to better understand how does that data behave in the end. That's exactly what I'm doing. So the data source is connected. I'm able now to have it navigated. So here the data sources can be considered as the data catalog for the data scientists, right? So they are able not only to see the list of data sources that they have available per project, they can and have access to shared connectors and connectors that were set up for their work, but they can also explore in more detail the data. This is definitely what I consider to be one of the most important steps, not only as a data scientist, but as also someone that is planning, for example, um, the next months of a data science project. So, uh, of course, I can have a very good overview of the size of my data set, but most importantly, I'm able also to understand the challenges, problems, mitigations that I might need to do on my data. For example, and particularly for this data set, I can very easily understand that I do have some variables that hold no information relevant for the churn, mainly because they are all the same all across the data sets, such as the count, the country, and the state. But I also can see that I have several variables that hold high correlation, which can mean a problem of linearity, which of course brings challenges for the capabilities of my classifier, for instance. But I also can see, for example, that given the size of my full data set, maybe I do have variables with a cardinality that can bring a problem of dimensionality. So based on these insights, I already know that I'll have some work to be done at the level of the data preparation, not only in terms of feature selection, but also at the level of feature engineering, for example. This already gives me a quite good understanding of how ready is my data set for the development of AI, and whether or not I'll have the information required, for example, for the development of a use case. This is how, for me, and why the profiling is so important in this use case, and particularly in this customer churn. I'm already able to get some of the information that I need in order to design a better data workflow for the preparation, for instance. As I know, this is a data set that I have labels, so I do know which customers have churned, that information is available. I'm also interested in understanding a bit more um, of the behavior of my target column. So, and that's exactly what I'm going to do. For example, I can very easily select my target variable, which in this case is the churn value, where I can see that I have a problem of how imbalanced is the churn value. Of course, this, and by looking into the logic of the business that we are exploring, it is normal and expected that churn has less representativity at the level of the data set, but that doesn't mean this is not something that we shouldn't take care of. Machine learning models sometimes they don't they do need um, a better understanding of the behavior that we want to map. In this case, it's the churn that we want to map, and that means that definitely we need to enhance the signal of the pattern around churn, and that's exactly what we will need to do. So there is a need to address this imbalancement, or at least that's exactly what we will explore, the impact of balancing the data set and how that affects the end results in what concerns the prediction of customers that might or might not churn. But of course, the profiling is not only about warnings, univariate analysis, but you can also take more information on the multivariate perspective of the data set by checking, for example, the interactions between two different variables and see whether or not they are related in some way. We have the correlations, which are always very informative in any development process, and also the missing values, where we can understand whether we have missing at random behavior, and definitely, as you can imagine, this can have an impact on the decision on how will we deal with the presence of missingness within the data. Well, before jumping into the next stage of the use case, I want also to very quickly cover with you um, how we serve the synthesizer through the UI, um, which would fit, for example, use cases where definitely we are more interested in making the data available due to privacy concerns. So the creation of a synthesizer is fairly simple. We can just select, for example, a data source that we have already available, or even create a new one during the process. I'll just select the one we have available within this project. Uh, we configure in terms of data types and variable types. This can have impact in terms of um, results of the quality of synthesis. Select the target in case this is a supervised use case. This is mainly important to measure the quality of the synthetic data, but not so much for the process of synthesis. And that would generate then a trained synthesizer that we can use, for example, to generate as many records as we want. For example, I'll just set here the number of records, leave it should generate, but I also can have a good understanding of the quality of my data at in metrics such as fidelity, utility, and privacy. All those metrics are delivered in a PDF report that you can very easily share within your organization. And that's highly useful either for compliance or even to share with different teams to create trust on the synthetic data that they will be using to develop a use case. But of course, we are talking about in this workshop, we are exploring um, the development of a data-centric approach for customer churn, where we have some challenges such as high cardinality or even imbalanced data. And in that perspective, synthetic data is far more useful if we can integrate into the process of data preparation and machine learning development rather than just not being able to have it integrated at all. For that reason, we are not going to leverage this particular synthesizer, but we are going to leverage YData SDK at the level of the labs um, and integrate the process of data synthesis at the level of the pipelines themselves. I'll show you how. Getting back to our data source um, and jumping into our data set, we can very quickly use these exploring labs that will provide us a code snippet that allow us to consume the data that we have created at the level of the data sources within the labs. This is highly useful if we want to integrate into a full data science flow the data that we have just created. As you can imagine, there's nothing more important than a full integration of the data sources and the profiling that you see in the UI at the level of the area or where the data scientists do explore further and do their developments. And that's is what we consider to be the labs. Labs are that space. So I'll just create one. Let's say this lab, I'll call it, it is the process, the step of reading. I'll just paste my code snippet and give it a go. What this code snippet is doing is nothing. It's just consuming the data from the connector that we have previously created. As you can see here, I have generated not only the data set or access to the data set, but also the metadata itself. That is where I have the definition of whether my variables are categorical, numericals, but also, and this is very useful, I have, again, the information that I've consumed through the profiling. So I have the warnings, which is what we can use, for example, to automate or to build a full flow of data preparation. Let's say that I know that missingness needs to be processed, and I know that I want to always apply the median kind of imputation. I can just consume the warnings and saying that for all the variables that have a warning of missingness, then I'll perform the median for that column and have it imputed. That's the type of use case you can build. Of course, it will depend on your objective, but this is why it is so important to also have those warnings equally available at the level of the labs. I'll just demo very quickly how you can, for example, as well, create a pipeline. As I mentioned, the pipelines are building blocks that in this case are built in a drag and drop kind of manner. And this drag and drop is fully based on Jupyter notebooks, which are already familiar and are already one of the most important tools for the development of data science. Here, I'll just drop my notebook. I'll configure what infrastructure will this step of my pipeline leverage. For example, I want the YData CPU image for reading data. I do not need GPU. I know this is not an intensive workload. For that reason, I'll just set one for CPU, but you are the owners of your data, you know your processes, and that's the beauty about pipelines. You can set up for different steps of your data preparation, different needs in terms of infrastructure, CPU, GPU, and RAM. That way, for different type of workloads, you can very easily select and optimize your infrastructure, which is very important cost-wise, of course. You are not, it is not needed for you to use, for example, GPU for a whole process if you only need it for one step. But we also have flexibility such as, for example, setting some steps with Python, others with R, and having them combined. This is very important when you want to build a use case in a very collaborative manner and you have two teams with different skill sets. So there is no need for one of the teams to learn a totally different language, right? So that's the type of flexibility that the pipelines can also provide you, but not only. For the particular use case that we are covering in this workshop, the customer churn, I have built this pipeline, which consists into several steps, being, of course, the reading the data, consuming the data, engineering or processing the data, giving the challenges we have found within the profiling, and last but not the least, building a classifier that we can use to predict which customers are going to churn, which is in the end the objective of this use case. As you can see, this pipeline has a set of steps defined, such as, for example, the profiling of the data, which is still important to be done at the level of the pipelines. The pipelines are elements that allow us to build comparable, traceable, versionable kind of workflows, which means that through time, data is expected to be updated, of course, and data can change. So nothing better than keeping your profile at the level of the pipelines. This allows you to compare how is your data behaving through time, how have it changed, how much have impacted your use case or your end goals and objectives with your preparation flows. And that's exactly why the profiling is so important to be kept. So it's a way for you to keep versioning how your data looked at a certain time. It's what I consider to be a true data snapshot. We also have some feature engineering, as I mentioned, for example, selecting the variables. We have done a split of the data and created a holdout to be used for comparison and validation of the results achieved. We have a step where we generate synthetic data for purposes of augmentation, for example, and last but not the least, of course, the fit and predict of a potential customer churn model, which is the end goal of the use case. So this is where I do define the structure of my code, but this is also where I can define some decisions to experiment different data preparation effects. For example, in this case, I have defined environment variable, which sets the synthetic data sample size, but also whether I want or not to generate synthetic data. This is something that allows me with the same structure of code to apply different decisions for my data preparation and make it comparable, versionable, and traceable. And that's exactly what I'm going to show you now at the level of the UI. So as soon as I save and create my pipeline, that pipeline is created here again at the level of the UI and generates experiments that I'm able to validate and check. For example, let's check this last experiment that we have done, original data with augmentation, for instance, and let's see how each and every step looks like and behaves. So for instance, I have here my data was read, but I have my understanding of the warnings. How do the warnings that were detected at the level of the data set, how are they? I do have, for example, my profiling being shown, so I can understand better for this particular experiment how does the data look like. I've also have, for example, further analysis on my data set after the creation of the holdout. And here I'm already making a more supervised kind of analysis of my data, trying to understand how different variables behave against our target variable. This allows me to understand the effects, right? And last but not the least, how my churn classifier did behave in what concerns F1 score, recall, precision. All of that, it's available for each and every step of my pipeline, but also, and most importantly, each and every experiment have their own results. As you can imagine, different decisions, different processings or decisions at the level of the preparation will lead to different results at the level of the metrics that we want to track. For instance, in this case, I'm considering for the customer churn, F1 score, precision, recall, but I also can consider more business-oriented metrics or objectives, such as how much will my costs to my business a churn of a customer, and what is my objective. So I want to minimize, right, the sum of those costs. That's the kind of metrics that you want and you should define at the level of this pipelines, for instance. But of course, for this use case, let's stick to the ones that are related to the machine learning models themselves. For instance, if we compare original data with augmentation and no augmentation, we can see there is an improvement in terms of the recall, for instance, which might be exactly what you want to target and to focus at the level of your objective for your organization. But you also can compare the original data against the synthetic data, both with no augmentation, allowing you to understand whether your synthesizer is being able to capture the behavior of the whole kind of population. And this tells you exactly whether your synthesizer will be or not useful for augmentation, to deal with bias, fairness, or even for privacy purposes, right? So this is exactly the type of comparisons that you can very easily do with the different experiments that you have built from the same exact pipeline, but with different decisions at the level of the preparation. And as you can see, all of this is versioned, all of this is traceable, and very easy to compare. And that's why these pipelines are so useful and so much needed to build what we call the data-centric approach of data science. It's so hard for us to follow sometimes how a specific decision in terms of imputation impacts the downstream application. And maybe we change that decision. And then how do we compare that change with the previous one without having to recode all over again? How do we make it versionable? And that's exactly what pipelines answer, and why it is so important to have them seamlessly integrated with tools such as the synthesizers, the labs, but also with the consumption of data at scale. I hope you have enjoyed the use case, the pipeline that we have brought, the data-centric approach for the development of a customer churn use case. And now I think we have some time for some Q&A. So I'll be eager to hear your thoughts, but also I'll be happy to revisit or do a in more depth, step-by-step ex exploration on some of the modules of our workbench.